You're given these directions from your house to Tracy's house. And then you're asked to write directions starting from Tracy's house going back home. I think the easiest way to do that is to draw a map based on these directions first. Then you'll be able to just look at the map to write your directions to go home. Okay, so from home, go north on Route 23 for 5 miles. Okay, here's Route 23. And we're going to go 5 miles. And we'll just real quick draw a little compass. Remind ourselves of directions here: north, south, east, west. So from home, go north 5 miles on Route 23. Turn east, which would be a right turn, on Orchard Street. So here's Orchard Street. And we made a right turn on that. Go to the 3rd traffic light and turn north, which would be a left turn onto Avon Drive. Okay, so we're going to pass 1, 2 traffic lights, and at the 3rd traffic light, we're taking a left turn onto Avon Drive. Then it says Tracy's house is the 5th house on the right. Here's Tracy's house. Okay, so there's my map. Now, if I'm writing directions from Tracy's house back home, I can just look at my map. So it says, if you start at Tracy's house, write down the directions to go home. Well, from Tracy's house, we need to go south on Avon Drive until we get to the traffic light. Okay, that's your first step of directions here. Go south on Avon Drive until I reach the traffic light. Okay, from there, we're going to make a right turn, which would be west. So we're going to turn west on Orchard Street. Turn west, in parentheses, right, onto Orchard Street. Once we're on Orchard Street, we're going to pass 2 traffic lights before we get to our turn. And we don't know if there's a traffic light at our turn. We were never told if there was a traffic light right there or not. So all we know is that we're going to pass these 2 traffic lights before turning south on Route 23. Pass 2 traffic lights before turning south. And that would be a left turn. So in parentheses, we put left. onto Route 23. Last step would just be to drive 5 miles and then arrive home. We were never told what side of the street the house is on. So all we know is that we drive 5 miles and arrive home. All right. Next question, it says, how did you come up with the directions to get home from Tracy's? Well, I drew a map and used the map to work backwards from Tracy's house. Okay, let's look at the next part. It says, suppose you are given the following algorithm, starting with a number, add 5 to it, divide the result by 3, subtract 4 from that quantity, and then double your result. It says the final result is 10. So working backwards, knowing this result, find the original number. So we ended up with 10. And the last step that we did was to double what we had. So if we had a number and we doubled it to get 10, we can find what that number is by dividing 10 by 2. So the opposite of doubling your result would be dividing by 2 to get 5. Step before that was to subtract 4. So if we had a number and we subtracted 4 to get 5, we can find what that number is by adding 4. We get 9. Step before that, divide the result by 3. So we had a number, we divided it by 3, and we got 9. So to find what that number is, we multiply 9 times 3. We get 27. The first step, we started with a number and we added 5 to it to get 27. So to find what that number that we started with was, we subtract 5. So 22 is the original number. Okay. Next question, write a function f of x, which when given a number x, which they're saying is the original number, will model the operations given above. So we're ignoring the work that we just did, and we're looking at this bulleted algorithm. It says starting with a number, add 5 to it. Okay, well, the number that we're starting with is x, a variable. So our function f of x starts with x plus 5 because we're taking a number x and adding 5 to it. That's the first step of our algorithm. The next step says we're going to divide that by 3. So x plus 5 divided by 3. Next step, subtract 4 from that quantity. So subtract 4. Then it says to double your result. So we're taking all of this that we just did and multiplying by 2. Okay, so let me show you an example of an incorrect function here. Your function should look very similar to the one that I've written. Here's what your function should not look like. If you wrote it all in the same line like this, x plus 5 divided by 3 minus 4 times 2, this is incorrect. Because this function, if you follow the order of operations, is not going to represent the algorithm that we were given. If you follow the order of operations, you're going to multiply 4 times 2, you're going to divide 5 divided by 3 before you do this addition and subtraction. And that's not what our algorithm tells us to do. So you have to write your function in such a way that when someone works it using the order of operations, it gets done in the same order that our algorithm says for it to. So this is incorrect. Okay, next question. Write a function g of x, which when given a number x as the final result, will model the backward algorithm that you came up with above. So now we are going to be looking at this work that we did. We're writing a different formula, or a different function, g of x. So in the work we did up here, we started with the final result of 10. So now we're starting with the final result of x. We're going to go through all the same steps that we did in that work. So the first thing we did was divide by 2. So we're starting with x divided by 2. The next thing we did was to add 4. So plus 4. Then we took our result and we multiplied by 3. So we have to take all of this and multiply by 3. Then we subtracted 5 from that. Minus 5. Now, based on the order of operations, this that's inside the parentheses will get multiplied by 3 before you subtract 5 anyway, which is what we need to happen based on our work. But if you want to make for certain that that gets done first before subtracting 5, you can always add some brackets here. It's not necessary to have the brackets, but it definitely doesn't hurt anything to have them. Okay, so this last part's not a question, it's just some information. Everything that we just did is called finding the inverse. The inverse is when the x and y are switched. Sometimes the inverses are functions and sometimes they are not. So that's going to come in to play on the back of this page. So let's look at the back. Okay, says find the inverse of each relation, and then it asks, is the inverse a function? So the first thing we have to do is find the inverse. This first thing that we have, just a chart of x and y values. So to find the inverse, we need a new chart. The numbers in our y column become our x numbers, and the numbers in our x column become our y numbers. Now, it's not going to look any different this time because they both just are 1, 2, 3, 4. But just for future reference, whatever numbers are in your y column are going to be put in your x column, and your x's become your y's. So they do switch, it just is not going to look like it here because they have the same numbers to begin with. So we have a new chart of our x and y values. Okay, now we look at the arrows. The first arrow that I see, we have from an x value of 1 to a y value of 1. So if we switch the x and the y here, they're both still 1. So we're still going from an x value of 1 to a y value of 1. That one doesn't change. Okay, if we look in our y column, we have a y value of 2 that has an arrow from an x value of 3. So when we switch the x and the y, now we will have an x value of 2 going to a y value of 3. X value of 2 going to a y value of 3. Okay, next we have a y value of 3 that came from an x value of 1. Y value of 3, x value of 1. Switch those, and we have an x value of 3 that goes to a y value of 1. And the last arrow, a y value of 4 that came from an x value of 3. If we switch those, we have an x value of 4 going to a y value of 3. Okay, there's our inverse of that function, or of that chart. The next question is the inverse a function? Well, I think it's first going to be easier if we look to see if this relation is a function. In order to be a function, you cannot have an x value that goes to 2 different y values. So if we look at this one, we have an x value of 1 that's going to a y value of 1 and a y value of 3. You cannot have that in a function. There can only be one y value associated with each x. So since we have an x value that goes to 2 different y values, we actually have 2 x values that do that because this 3 goes to 2 and 4. So we have 2 different x values going to multiple y values, which is not okay in a function. So we know that the original relation is not a function. So now if we look at our inverse, each one of these x values has only one arrow coming off of it. So we know it's only going to one y value. It's not being split and going to two separate y values. Now we do have x's that are going to the same y value, and that's okay. We just can't have an x value going to 2 different y values. So this inverse, we will answer the question, is the inverse a function? Yes, it is a function. All right, let's look at the graph. We're given a graph of ordered pairs. For example, I'm just going to choose a few points on this graph. And each one of these points has X and Y values as an ordered pair. So this point here has X value of -2, Y value of 0. So we have an ordered pair, -2, 0. This point has X value of 1, Y value of 3. So we've got 1, 3. This next point is 2, 2. This point is 3, 3. And the last point is at 4, 3. So I just made a list of some different points that are on this graph. And since the inverse means that the X and Y switch, all we have to do is switch the order of these numbers for each ordered pair. So now in our inverse, we're going to have a point that is at 0, -2. I just switched the X and the Y. See, these are our X's, these are our Y's. And they just switch. So this next point, now it's going to be 3, 1 instead of 1, 3. The next 2 points won't really change because even if you switch the X and the Y, it would still be the same. 2, 2, and 3, 3. The last point, switch the X and the Y, and we get 3, 4. Okay, so let's plot these points on our new graph, which I know that you guys are drawing this on your own paper. Just do the best that you can. Try to make it as accurate as possible. 0, -2 would be right here. 3, 1. 2, 2. 3, 3. And 3, 4. Okay, we know that our middle 3 points are the ones that created this little valley, this little semicircle here. So our middle 3 points here are going to do the same thing. You can kind of start right there, and then you can see pretty easily the shape of the rest of your graph.